viewers, welcome to my channel. My name is Saurabh Sharma and in this video we are going to discuss question number first of first internal of numerical analysis and design subset. So the first question given here is as here follow. So the question is write an algorithm to accomplish the task for polynomial px given in the following table. So in this question we have given a polynomial px and we have to perform certain tasks like evaluating the polynomial, dividing the polynomial and finding the differential coefficient of the polynomial px, and we have to write the algorithm for doing such task in by two approaches, which is iterative approach and recursive approach. So yes, so let's head to forward to the solution. So first we will gonna look over the algorithm to evaluate px using brute force technique. So for this first we will going to initialize a result variable to 0, and then we will run a for loop from where I is equals to n to 0 in decreasing order, and then inside this for loop we will multiply the coefficient of ai with x to the power I, and then this computed value will be added in the result variable of in the result variable. Yeah, and when this for loop will continue loop over, and then when this for loop will end, it will go to third step where we will add the value e0 in the result variable, and then we will return the result variable as the value of px. So yeah, then we will get the result variable which will contain the evaluation of px. So here you can also refer to this example. In this example we have taken a polynomial which is 2x to the power x cube plus 5x square minus 3x plus 1, and here you can see that we have initialized result to 0, then we run for loop from I is equals to 3 to 0 in decreasing order, and then we are multiplying value of ai with x to the power I. So you can see that in first approach, or when I is equals 3, this computed value is this, then we will add this value in the result. So the result value will be this, and in the second iteration the product value will be 5x square, and then we will add it in the result variable. The result will be 2x cube plus 5x square. So similarly in third iteration the computed value will be 1, and we will then add this value in result variable, and then at last we will add a0 in the result variable, and then return the result as the value of px. Now we will look over the algorithm to evaluate polynomial px, so given in the table using recursive relation or recursive approach. So here we will define a recursive function evaluate polynomial that takes 3 parameters. First is coefficient a, which is a list or array in decreasing order of degree. Then second is degree, which is denoted by d, and third is value of x variable. So inside function, if degree d is 0, then we will return a0, and otherwise return the value of the polynomial evaluated at x. So how yeah, so how we will evaluate x? So here are 3 steps given here, like first multiply the coefficient at degree d with x to the power d, and then recursively call the function with degree d minus 1 and add the result of step a and step b. So this recursive function will call itself again and again until this if condition gets satisfied, then it will return a constant value, and then in the result we will get the evaluation of polynomial px. Then here I have also mentioned example which uses recursive approach. So you can also refer to this example. Now we will look over the algorithm for dividing px by x minus r. So here first we will initialize the quotient polynomial q and remainder r to 0. Then we will run a for loop for each term of the polynomial from highest to lowest degree. Then we will compute the value of current term of coefficient. And how we are going to compute the current term of coefficient? By dividing the coefficient by x minus r. Okay, and then we will add this computed value to the quotient polynomial q and compute the value of the current term of the remainder by multiplying the quotient of the current term with x minus r. So that's how we will get the remainder, and then subtract the computed value from the current term of the polynomial. And in the last step of for loop, we will add the computed value to the remainder polynomial r, and then when this for loop will end, it will return the quotient q and remainder r. Now our last algorithm, let's look here. So in this we are going to write the algorithm for computing derivative of px. So here first we are going to initialize the derivative polynomial d to 0. Then for each term of the polynomial from highest to lowest degree, what we are going to do is that we will compute the value of derivative of current term by multiplying the coefficient of with the degree of the term and subtracting the degree by -1. Then we will add this computed value to the derivative polynomial d, and then in the end we will return the derivative polynomial d. So that's how we will get the derivation of or derivative of polynomial. So now we have look over all the algorithms of this polynomial. So thanks for watching this video. Thank you.